What was that laugh? What was that?
All right, let's go through these real quick here. Okay, so these are all questions that were on previous air tests. Okay, so this is how this material is going to show up. For number one, okay, we made this chart essentially, right? We wrote in all the properties. Okay, if we're looking at this, the way this chart flows, okay, we said, well, a special type of quadrilateral that a lot of others fall underneath of would be a parallelogram. Okay. Then we said, well, a couple different special types of parallelograms would be a rectangle and a rhombus. It doesn't matter which one's in which spot, right? You could have these flipped. And then the shape that shares the properties of both of those is a square. This question is going to be on the test on Monday. This exact question. I'm telling you right now, this question will be on the test on Monday.
Tuesday. Wednesday?
Friday?
Never.
Wednesday. Friday's too late.
No, like tomorrow, Friday.
Oh, no. I just barely passed.
I think that if you would just, actually do a review pass.
So the next few then, okay, have to do with slope. Okay. On number 2, it says we've got some square ABCD, right? So we talked about the order that the vertices are listed matters, right? It would look something like this, right? Obviously, I didn't plot any points, right? This is just how the coordinates would be laid out, A, B, C, D. So we know points A and B. We want to find the slope of BC. Well, what I know in a square is that consecutive sides are perpendicular. They form right angles. So if I find the slope of AB, all I would need to do is take the opposite reciprocal of that to get the slope of BC. So slope we know is y2 minus y1 over x2 minus x1. So my points I can label x1, y1, x2, y2, and plug them in. So y2 minus y1 will be negative 4 minus 2 over x2 minus x1, 3 minus negative 1. So negative 4 minus 2 would be negative 6 over 3 plus 1 would be 4. So the slope of AB is negative 6 over 4, or we could reduce that to negative 3 over 2. So if my slope here is negative 3 over 2, the opposite reciprocal of that would be positive 2 over 3. Okay? Or if you had positive 4 over 6, that would be fine as well. Okay? The air test does not penalize you for not reducing. Okay? So I will not penalize you for that either.
Wait, so why do all these teachers make contributions?
Why do what?
Every other step is reduced. It don't matter what you.
I'm just following what the air test says.
Next year you'll have to reduce again.
Yes.
Good thing I'm dropping on.
Number 3 is a similar problem. Okay, we know this is a rectangle, and it's also called ABCD. But this time, I'm given points C and D, and I want to find the slope of AB. Those are opposite sides this time, so they will have the same slope. Okay, so if I find the slope of CD, that's just my answer. Okay, so again, y2 minus y1 would be negative 3 minus 5 over negative 1 minus 1. So -8 over -2. Negative over a negative is a positive, and then 8 divided by 2 would just be 4 over 1. So since the slope of AB is 4 over 1, the slope of CD is also 4 over 1. Right? So in a problem like this, and there will be problems like this on the test on Monday as well, right? Make sure that you sketch out a situation real quick, right? If it's asking for a consecutive side in a square or rectangle, we know it's opposite reciprocal slopes. If it's asking for an opposite side, we know it'll just be the same slope, okay? On number 4 then, it asks us to find the 4th point. Okay, so on something like this, we definitely want to graph this, right? You have access to Desmos, so use Desmos, right? So I've already typed these into Desmos, so this is what this situation is looking like. Now, we know that if we type all the points into the same line and put commas in between them, we can draw the lines, right, on Desmos. All you need to do is put them in the same line, separated by commas, and then click and hold over here. Oops. And it'll give you a few options. One of them is to turn lines on and off, which makes it a little easier to see where the shape is. So I can see that my other point, my other vertex is going to have to be up here somewhere, right? Well, to figure that out, we just want to think, well, opposite sides are going to have to be the same length and parallel. So to go from here to here, I'm going to go up 1, 2, 3, and over 1, 2. So to go from here to here, I'm also going to go up 1, 2, 3, and over 1, 2. That's where my 4th point would have to be, okay? We want to use the graph to do that. So that is the point 0, 4.
Okay.
Okay. We okay with something like that?
Yep.
Okay. Then on number 5, I think I messed up, right, in labeling it. So I already flipped it on this paper, but if you flip your C and D, okay, if you make C 0, 6 and D -2, 3, then it does work out. Yeah, I messed that up. So if you flip point C and D, we get this shape here. Right? So we've talked about different ways to determine if something, or what shape something is, right? We want to see if opposite sides are parallel. That would tell us if it's a parallelogram. So I'm going up 3 over 2, up 3 over 2. So these sides are parallel, and down 2 over 3, down 2 over 3. It's at least a parallelogram. Then we can go one step further and say, well, since those slopes were opposite reciprocals, right? This one was -2 over 3, and this one was +3 over 2. These are right angles. So then I can say it's a rectangle. Then we can even go one step further and find the lengths of these sides, okay? That would tell me then, since all 4 sides end up being the same, it is also a rhombus. If it is both a rectangle and a rhombus, it is a square, okay? So this one ends up being a rectangle, or a parallelogram, rectangle, rhombus, and a square, okay? Then finally, the proof. Okay, and this is a proof that was pulled directly off of a previous air test. They tell us that this is a parallelogram, then opposite sides have to be parallel because it's a parallelogram. Then they say, well, angle ZWY has to be congruent to angle XYW, so these two, and angle ZYW has to be congruent to angle XWY. Those are alternate interior angles. Then they say WY and WY have to be congruent. Well, same thing, congruent to itself is the reflexive property. Then they claim the triangles are congruent. Well, if I look, I've got angle, side, angle. I've got two pairs of angles with the side in between. So those triangles are congruent by angle, side, angle. Then finally, they say, well, WX has to be congruent to YZ. That would be because, since we've shown the triangles are congruent, corresponding parts are congruent.